Now, when it comes to AI, we have a lot of caveats we have to look out for. And so prompt engineering goes a little extra further than it does with humans. Prompt engineering is about understanding how to frame a question, how to frame a problem. Okay. And so it's just as much being a good manager and a good communicator.
Welcome to AI Experience, the podcast that demystifies artificial intelligence. My name is Julian Rodelsberger, and we are going to find out how AI is changing the world. And I'm super happy to welcome Daniel Wilson. He is an AI and data sovereignty advisor to the Malaysian National AI Office, where he helps shape national strategy around ethical and secure AI deployment. He is also the CTO of Cyber Intel Training and founder of InfoScience AI, where his current focus is on cognitive computing. So today, I want to take that opportunity to talk to a real AI expert to discuss something that is linked to generative AI, hallucinations. What are they and how do we deal with them? Thank you for joining me. How are you today, Dana?
Great. Thanks for having me, Julian. It's wonderful to be here. Excited to be a part of this. Yeah, excellent. Thank you.
Yeah, thank you. Thank you so much for being here with me today. So let's maybe, Dan, start with the basics. Could you just explain us what are hallucinations and why do AI models hallucinate exactly?
Yeah, exactly. So, neural networks and machine learning and all the things that we see that have created AI today in modern terms are a product of what's called inference. And, when we use a calculator or we use basic math, we can deduce and we can logically discern a very definite type of inference. So, deduction is a type of inference. But inference itself is a broad term and it refers to conclusions drawn from premises or evidence with specific type of inference where conclusion is guaranteed to be true if the premises are true, but deduction moves from general to specific. So what happens is with inference, it's almost like a guessing game. Okay, what's probable? So using probability isn't quite like deduction, because there's again, it's speculative. So our minds, our brains as humans, we're really not geared to memorize large chunks of data. We're in environments where things are constantly changing. And so it's our real time dynamic senses that really give us our edge. Okay. But the way that our memories work and are stored vary depending on how a situation might occur. And so our limbic system will help us manage episodic memory, which means episodes like you have something happen to you and your friends. Everybody can tell that story. Everybody has their own version of that story. Okay. Now, the story's true, but the differences are based on a certain type of inference or from a perspective of where someone was coming from. Okay. And if someone forgets, someone might have the rest of the story and can help remind you. Okay. And that might be a form of deduction to some. But on our inside, when we recall a story, we're not telling it the exact same way every time unless we have a bit, unless we have a routine. So it's like being on stage as a stand-up comedian. Perhaps you have this routine, you do this story, but even then those comedians will tend to vary their story every once in a while. It's never the same. And so, while yes, there are people who can memorize large, quantities of numbers, like certain digits of pi, okay, beyond certain floating points, we're still not geared to do that, physiologically speaking. We have to put a lot of extra effort into that. So these inferencing machines that are, large language models, just on their own, without any kind of framework to control them, are really good at guessing, and they're profoundly good at being convincing and sounding convincing. So, for example, we only have so much room to work with in our working memory. Okay. And so I might have to write something down or take a note. Well, the AI or the LLM is quite the same in that it has a context window that's definite and finite, and it will fill up. And after a while, it sort of has to flush its buffer. And so, if at the very beginning of a conversation, you start talking about a few things like apples, and then 15 minutes later, you're not talking about that later on, those words might not be a part of the context window anymore. And the AI could hallucinate, so we say, okay? They actually are hallucinating machines. They're made to hallucinate, okay? So, prompting and other types of guardrails help create a more intelligent interaction a more conducive to logical flow. But we have our limits, and because AI is built on the same type of neural activity that we are, it's susceptible to the same types of hallucinations. So I might not recall off the top of my head something, but I will do my best to find a convincing thing to say that's going to be close to it. And that's that for hallucinations.
Okay, so thank you, Dan. So, what would it take for a machine, an artificial intelligence, to not hallucinate? Would it be a matter of hardware, getting more hard drive, more server bay, more memories?
Yeah, so the transformer architecture is what it's called, and that's what a large language model is built on. And essentially, it's transforming these vectors that are related. Okay, so a word, or sometimes, groups of words or small letters could even be tokenized. And when all that's formed into a vector database of some sort, this is like, I'll make this easy. It's a big soup of inference. It's sort of like all the words we have in our head. Okay. So on its own, the LLM doesn't really have the ability to not hallucinate. It is the systems around it that manage the conversation that allow it to do better. Okay. So if you look at a human brain, has various parts, and then a lot of those parts work together for certain functions as a group, right? So the mammalian brain will give emphasis and signals to the limbic system, and it's part of it, in order to figure out what to do in certain situations that could be physical and not just mental or what have you. And so the way that memory is managed is different. Okay, we don't have time to think about the past. Our bodies will react if we're going to slip off of a log or something. We'll remember, oh, I got to catch my balance. But that's a memory too. And so, with LLMs, in order to keep them in the rails, we have to have an intelligently managed context window, not like we have been doing it thus far. Okay. I have the ability, and you have the ability to run a large language model, but a smaller version at home on your computer. And when you do, you can have a basic chat session with it. Okay. But there are not a lot of the same guardrails in place and memory management frameworks in place that there are on bigger platforms like Claude, OpenAI, Grok, Meta. All these have their own management systems that they have brewed themselves. Okay. And that means that it might reincorporate things into the context to make sure that things aren't lost. There might be some invisible system prompting behind the scenes you don't know about. But the brain does this too. And so if you say, oh, AI, well, AI is a lot of things, okay? But that large language model is only a small part of our brain. You could say it's like a memory pocket. But the systems that engage that hard drive, if you will, that pocket of memory, okay, that we have, is what really provides the intelligence and the management for that. So it's not merely a storage system; it's a system of inference with a dynamic connection to the 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 what's being what who is querying that system. Okay, and so that's the gist on that.
Okay. And so does that mean that maybe ChatGPT would hallucinate in a different way than Gemini from Google or Grok or Mistral, Claude, etc.
That's right. Yeah. So if you don't reincorporate, like for example, with human conversation, we meet in a day and we talk, and it's 10 minutes into the conversation. Okay. You and I are not referring to the very beginning of the conversation. We're referring to whatever few last interchanges have happened that are carrying the actual weight of what's the meaning of what we're talking about. Right. So there's a lot of logic in, throwing out data too. We can't live with all of the frequencies around us and take them all in at once and have a discernible life. It would all be white. We would not see contrast. We would hear so many more noises than are applicable to our experience, to give us benefit, right? So too much noise or too much data has to go, right? So there is something to be said about that kind management of the short-term working memory. Okay. So while yes, this is a reflection of human nature and human thought to a degree, it's merely a it's merely a simulation of a small fraction of it, right? So yes, so Chat GPT on OpenAI might hallucinate differently when it does than on Gemini. Okay. And I say this because even now you can use the built-in memory system on ChatGPT to be aware of all of your conversations. They just released this last week. I've been working on this for over a year and a half. A lot of my work went into this back in 2023. And so now I'm working on a variety of more advanced systems on my own. But it's, yeah.
So Daniel, you've worked on, and I quote because I have no idea what it means, neuromorphic systems and cognitive architecture. Could you explain in a very simple English what this is about?
Yes. So we're when you talk about the large language model itself, that's part of the picture. But again, we need other parts of the brain to be simulated in order to actually supply a more conducive, more I want to say integral type of conversation where it knows the limits of what it knows. Right? You can use a lot of different tricks and prompting to keep things going. But on the large, it's the actual architecture that it's built on. Okay. So, for in contrast, an LLM is using transformer architecture, but a state space model that is being used for voice uses a different type of approach, and it deals with math in a different way, and it can be more effective for certain things, right? So there's different types of models that we use in machine learning and neural networks that aren't really mentioned much and are not as popular for people who are non-technical, like Gaussian inference, state space models, different types of math algorithms with different constraints that allow different operations to happen more equivocally for certain reasons, right? So you might find that conversations with Gemini don't quite have the same effect as OpenAI, or Grok might be more profoundly edgy with you and say, I don't think your idea is good, right? You need clarity. You're not going to be convinced that your idea is perfect. You're going to see if is my idea formidable, and I'm using this LLM, this AI, to help me determine what I should do about something in real life. I don't want to play a guessing game, right? But there's a part where it becomes a guessing game, You might have a conversation with a real person who can't, after so much technical talk, they may have to go back and look at their notes, right? Depending on what it is. The LLM doesn't have that capability unless the developers who run the chat platform have built that system in on the side. And so it's sort of patched in from the side. We're only we're only just now getting to parts of simulating parts of the brain. So it's new, it's emerging. Yes.
Yeah, no, I understand that, and for the listeners that want to know how to reduce hallucinations when using a LLM, a generative AI model, what advice can you share? Is it, for example, like the prompt can make a difference? The way you use the AI can make a difference. The number of information you want to share to an AI can make a difference. Like, how do you reduce hallucinations?
So awareness, the unfair part about this is a lot of people don't know either one, how large a context window is when they go into a chat, or what even a context window is, or how it works. Okay. So if you say, I have a piece of paper, it's a blank sheet of paper, and when I start writing at the top of it, I'm going to reach the bottom of the paper. Once I reach the bottom of the paper, it moves up, and whatever the first thing I wrote on that paper disappears from the top line. Okay. If you drop a whole you paste a large article into the chat, you know, just text, that might be so large that it doesn't have enough context window to juggle all of your questions and keep that into the frame. Okay. So, on the large, and practically speaking, no matter what platform you're on, as soon as you come to the prompt, and let's say it doesn't have very big window of context, that's okay. There's ways to manage this. And the way that works is by reincorporating things that are meaningful and keeping it into the conversation while you're talking and bringing it back in. Okay. So there's a thing that happens that's important for everyone to know. And that is that in the human brain, our neural networks have the ability to activate and wake up depending on what we experience. A great example of this is driving a car. When you're walking up to the car or you're even thinking about it, your neural networks in your brain and body's physiology wake up a certain way, trigger and activate, and get ready to do a series of actions. Before you even think about it, you've sat down, put on your seatbelt, looked at the mirrors, maybe adjusted one, checked a few other knobs. and then look behind you to back out, perhaps. Okay. All this happens in the blink of an eye without us really having to do anything. And that's one of the beauties of our human bodies, okay? But we're pre trained, just like a pre trained general transformer is, GPT. General pre trained transformer is what that is. So we have these neural networks. So when you have a conversation with an LLM, if you just picture a brain and you can see different highways in that brain like activating, like lighting up. Okay, once you start having a conversation, it actually keeps a certain amount of performance in that frame based on what you're talking about. Okay, so as long as you keep your conversation fluid and you keep incorporating things that you know are important, you can maintain a wonderful long conversation well beyond the bounds of the context window. However, the moment you lose track of that, things can go sideways. And I will give you an easy example. And has to do with deduction too, okay? So because they're not deducing, they're inferencing. It seems like a deduction from the outside, but the math that they do is an extrapolation of tricks. I know this is this, therefore, if I do these things, this should be this. But it's not always correct because, again, it's a guess, it's inference at the largest degree. Okay. So, what you can do is be very specific with your prompting and state and reestablish exactly why you're doing a certain thing at certain points. So, my technical example is that I want to use AI to write some code. I'm going to write some Python code for whatever. It could be a graphic screensaver, it could be a web page, what have you. And as I am using AI to produce and help me develop code, eventually that code might become so large that it forgets why it was trying to fix a certain part of it and for what reason. And it might hallucinate a variable that wasn't there. And this happens to people out there where after a while, you've actually kind of messed up your code because the AI got so far off track, you never reestablished why you were doing what you were doing. And so if you have some large, let's say that you have a project that's in three parts, okay? I want to work on this part of my story, this part, and then this part of my story. Well, if you spend a whole lot of time working on the first part and the second part, by the time you get to the third part of the story, if you're trying to loop back and incorporate elements and characters and, plot twists from the very beginning of that story, it might have lost it. And when it does this, this is a logical thing that happens, but it creates an ocean of illogic to us, right? Like it gets there by stepping through a frame of reference, it's a working memory.
And so, what advice could you share to developers, writers, anyone who would be using a generative AI model to avoid hallucinations?
Right. So on the user end, because you won't have any control over the memory management platform of a chat session, is to just be mindful of your original instructions. So you could take let's say, for example, a notepad, and you could write the very precise and and well thought out reasons that you're doing something or what you're aiming to do, and then every once in a while copy and paste that back into the session to say, well, let's keep in mind these are our goals here. Okay, don't forget these are our constraints. And if you do that every so often along the way, it'll keep up. Okay, so an example would be I have a lot of variables in a program. Another example would be I have a lot of characters in my story I'm writing. Okay, which is a really down to earth example. And if you don't reestablish what certain characters are doing, it might lose that. Okay, and it might start hallucinating what they really do when in fact it's not quite what they were supposed to do. Okay, again, we're left with the limits of a frame of reference. It's the human mind trying to juggle so many numbers at once. It will find a limit and it will fail, and you will come up with what you thought was the truth when in fact you were hallucinating yourself. Okay, so it's just mindful prompting and reinserting your original intent will really help the end user.
When I talked to my guest on the podcast, some said prompt engineering is a key job or a key skills. What do you think? What is for you prompt engineering? Does it matter? And is it something everyone should master? Is it a job or a skill or nothing at all?
It is. It is such a profound thing. It's larger than prompt engineering is giving good instructions is prompt engineering. Okay. Now, when it comes to AI, we have a lot of caveats we have to look out for. And so prompt engineering goes a little extra further than it does with humans. If I say to an assistant of mine in real life, I give them instructions to go to the store, pick up these items. If they don't have this, then replace it with this. And for these reasons, if they don't have either, do not get anything else. You have to be specific. So, prompt engineering is about understanding how to frame a question, how to frame a problem. Okay. And so, it's just as much being a good manager and a good communicator. We are constantly prompting ourselves and others in real life. So, prompt engineering is the art of communication. And so, it's important to communicate thoroughly with the LLM.
Do you think we can ever trust a model to self check its own hallucinations, or is it just too complicated?
I have often wondered if it's possible to write that into the actual normal transformer models. Okay. And there is something to be said about that. You can wrangle something like that. What people don't know a lot of times is there are settings that these models have when they run. Okay. And one of those very basic settings is called temperature. And temperature is just like you could imagine giving the AI alcohol, and the more you give it, the more wild it gets, and the more. But temperature is giving it. You raise that number to 9, and all of a sudden it's very creative, way too creative. But you lower that number, and all of a sudden it's more consistent output. A general user doesn't have the capability to just change that most of the time, unless you have your own system at home like I do. But even then, there is that. So you have to build this into a framework. What I have found is that when I prompt, there's again back to your prompt engineering, it's important for you to invite it to self scrutinize and to scrutinize what you're talking about. Please let me know if this sounds okay because I don't think it does. Are you sure? You could almost start with a negative spectrum of it. I don't think this is true. Help me prove this false. And it might not be able to because you have given it something true. Okay. So on the large, you have to be very managed with it. You have to kind of keep up with it yourself because there's no framework you can guarantee. You must use mindful prompting and reinserting things.
Okay. How far are we from an AI system that would say, that would truly know that don't know that? Like, can we teach models to say, I have no idea convincingly? And why AI always try to please us instead of saying, I don't know. I don't know how to answer your question.
That's right. Yeah. The nature of its transforming and actually inferencing and producing word output is based on this way that it works. It doesn't have control over those limits. And so it cannot convince it will do its best to be self-checking in that sense if you tell it to, but you have to stay on it or it might forget. It might go outside the context window. It's almost like that rule. The last rule you give me is my mandate. So if you tell me a bunch of logical rules, but the last rule you tell me gets me to negate those rules, it's going to go with the last rule, you see. So there's some internal twists to that, but because it really doesn't know, it's like a drunk friend who can't keep up with certain things anymore. It has its limits, and where those limits are very convincing, and by default it is programmed and pretty much built to produce results based on a request. So it wouldn't know that it didn't know. I think that's the important fact. It's like the drunk friend. It doesn't know that it doesn't know. And I used to know it. We had the conversation an hour ago, but now it's inebriated. And so it's so far removed from the original train and chain of thought in the conversation that it gets off and falters. This is why we must use external systems to double check what we're doing for now.
So, Dan, could you explain what is AI explainability, and just to see if we should invest more in AI explainability tools to help humans spot hallucination?
Okay, so the explainability for AI starts at the level of where it was built. Okay. And so the reasoning behind and the exact logical steps how AI gets to an answer is called a black box because of the way it works. We don't know exactly how it gets from point A to point B sometimes. It's not exactly mapped. It's not something that we have our finger on the pulse of. Okay. So we don't know in that case. Let's see here. But the explainability comes not just, like I said, weights and how we trained it and the data that we trained it on, but when it comes down to it, when it's putting that all into action, that's where explainability gets off. We could say, well, we gave it all this good data. We know we trained it on Shakespeare, we trained it on all these great authors, and so we know exactly what we did here. But when it all comes together, there are things that you can't not explain on the inside quite exactly. And it's almost like a mood. Like we have different moods. Our body might be tired. We might be hungry. We might be on a lot of coffee. Who knows? And so there are a lot of things that change our explainability on the inside. So what we're doing now and what people are working towards are more hybrid systems with different architecture that allow this logical safety catch. Okay. But this is a very evolving and current art. It's not a science, it's an art. The science of the brain is there, but the art of transcribing that to a large language model is very much growing and in its infancy.
Can you think of any situations where hallucinations are actually a good thing? I'm thinking, a writer looking for a new story, but is there anything else behind that to fuel the creativity, maybe?
Yes, so hallucinations are a good thing. They are a feature, not a bug. Okay. So all of the output that you see from any LLM is, in fact, an hallucination. It's just working out for us. That's all. Right. So, as a musician, if I say, hey, I would like to, you tell the AI to write something a certain way, and then it comes back and says, use this chord progression. That's very useful. Okay. Oh, I want to do something a lot like, this one art, pianist like Scriben, but I want it to sound like this, of this other artist. And so the hallucinations become very useful, right? I like Alex Gray. I like H.R. Giger. I like a lot of visionary artists who use math and tessellations and other things, right? And so for me, if I put that together, oh, hey, when you're using image generation, that's an ultimate hallucination, to a T, so it's very useful. But we hallucinate all the time, okay, as humans, and we wrangle that. I'm not talking about visual or hearing things, but I am talking about the act of creating and inferencing something that's new. And so hallucination is a feature. It's important. It's all they do, in fact. They trick you into thinking that they're reasoning when they're not. They just sound so convincing because of the nature of their training and the nature of those weights behind it. Now, remember, our brains and our own values, we determine the weights on the insides of ourselves, what matters, But the way something is programmed is, it's all going to come down to its exact programming. But once you turn that on, the nature of the machine is pure inference. Therefore, hallucinations are all you're going to get. So, without that surrounding framework in a chat session, without these other tools that you don't really see used, like on OpenAI and other things like that, you'll have a profoundly large amount more of wild hallucinations versus useful ones. So it's just a matter of perspective. That's all. That's all. The water is really good for you until you're drowning in it, right? So,
Exactly. So then, me one last question for you. You've been working in AI for a very long time. Did you see any progress in terms of hallucinations over the last few years?
oh, absolutely. From watching Chat GPT in its infancy come to 3.5 turbo, and then after that, 4. Once we had Chat GPT 4, that's when things became way more profound. And a lot of that had to do with a larger context window. It's a brute force approach, but if you just give it more power, a more scalable context window, you can actually overcome a lot of the limitations that you would see, a lot of the shortcomings that you would see in older models. There's a point where if you keep going larger, a human may never know, and it seems perfect, but it's still using inference to get there at a large degree, right? It's not deducing.
Perfect. Well, thank you so much, Dan. So at the end of each episode, the guest answers a question posed by the previous guest. After that, you'll have the opportunity to ask a question for the next guest. Are you ready?
Okay.
All right. So here's your question, courtesy of Boaz Misrahi, who is the CTO of Tactile Mobility. We can listen to his question right now.
How will you prove the robustness of your AI driven solution? When you are answering it, try to avoid the statistical testing as an answer.
Uh-huh. Yeah, you would have to automate the deductive. comparisons, you would need to actually check an external corpus of data to find. You would have to verify those answers outside of the field of inference.
Perfect. Good to know. Thank you so much, Dan. So now, what question would you like to pose for the next guest?
This is a good one. This is technical, but this is also a matter of perspective, okay? And this is about security through obfuscation, and obfuscation means to hide something or try to, keep it like camouflaged. So, they say security through obfuscation is not security, okay? So if that's the case, why is it that there is such a strong argument for closed systems and closed models when an open model could be just as secure, if not more secure, based on the integrity of its architecture?
Wow, perfect. Thank you so much, Dan. It's been an absolute pleasure speaking with you today. Thank you for joining me.
Thank you so much, Julian. It's wonderful to be here. I really appreciate it.
Thanks, Dan. And that wraps up another episode of AI Experience. Thank you for tuning in, and we'll see you next time. Hey, thanks for listening. If you enjoyed the show, don't forget to subscribe on your podcast platform. Your support counts and your comments can really help share this experience with others. You can also visit the website ai-experience.io to find out more. See you soon for a new episode.